Welcome. Executive Director for Hurricane Island Center for Science and Leadership. I'm incredibly fortunate to work this wonderful organization that your kids have been engaged with all week. And thank you so much for sending your kids. We really appreciate it. The students and the work that they do is the core of our work. And we really value having them out there, especially this is a longer, more immersive program. And we really value that and what your students are going to be presenting right now, because that our work is to integrate scientific education and scientific research, and to have our students engage with scientists, have our students doing real scientific work, and then collecting data and presenting it. So you're going to hear some about that this week. Special thanks to Claire and Riley, who are their instructors this week. I'm going to have them come up and talk more about your students' work this week, or your kids' work, their students. Maya and Callie are MMA interns right here, who also worked with these kids, and I'll let these guys talk a little bit more about, or maybe the students will talk about how they worked with Maya and Callie, but from Maine Maritime Academy. And that's a really exciting partnership that we have that's emerging. So thank you so much for being here. I'm going to turn it over to Claire and Riley and take it away.
Awesome. Well, welcome to this super exciting presentation from the kids.
We're super glad that you could join us today in order to see everything that they've worked on. We did a whole bunch of things on the island, lots of fun, lots of labs. But the main thing that carried through the 10 days was this marine science research projects that they worked on. They came up with their questions, they came up with their hypotheses, figured out how they were gonna find the data, figure out their methods, and then put it all together into these presentations. So one of the great things that they all got to work with this past week was the flow cam that came from MMA, which they will also talk more about. But a really great tool to look at a whole bunch of plankton in the water.
Yeah. And I think they will cover most of the rest of their specific methods and everything they got to do, but they really did have a very varied week of lots of time on the boat, a trip out to Seal Island, which you'll read all about in this room, which is cool. We were out there looking at some awesome birds. So they did a ton this week, which they'll get into for sure.
And if you haven't already seen pictures that we've started uploading, you can look at those.
Will you be on Facebook or?
They'll be on a Google Drive.
Frightening them.
Yes. Yes. All right.
Do you guys want to start?
Okay. Nuclei off of Hurricane Island. So a little background, we learned a lot about phytoplankton and zooplankton in our time at Hurricane. We learned that the zooplankton are on the bottom of the ocean during the day, and the phytoplankton are on the top of the ocean during the day. And then at night, they sort of switch. The zooplankton migrate up to eat the phytoplankton. And our research was based off of that sort of concept. So our research question was, how does the number of nuclei differ from change of depth and time of day? And our hypothesis was the number of nuclei on the seabed during the day will be similar to the number of nuclei on the surface during the night. So after collecting our research, we made a chart. We sampled from 2 sites. At night, at 8 meters, there were 13 nuclei. So 8 meters down is sort of a middle range. At site 2 during the day, 13 meters down, there was 0.
Surprising to us.
Surprising.
Sir, please wait.
So the day samples, both the day samples we collected from the bottom of the ocean, had no zooplankton in them. Absolutely no nuclei. And that was a big surprise to us. And then off the dock, on the surface, and at site 1, both at night, there were 8 nuclei and 1 off the dock.
Yeah. So in conclusion, our night samples were accurate to our hypothesis, but our day samples were very surprising to us. We came up with a few reasons on why we thought we found no data during the day. One of which was that this time of year is the end of the fish cycle, meaning that nauplii are turning into bigger zooplankton like copepods, and they are also being eaten by small fish, so that could explain it. And then another reason might be like the current in the channel. There's a pretty strong current, and nauplii can't really swim that strong and fast, so maybe they like hanging out by the shore more.
Yeah, so, our method to like collect all this data was, we were at two different locations, during the night and day. And we got samples from like deep in the water using this thing called the Niskin bottle. And from the surface using like a surface trawler net. After that, we filtered the water through a like 1 millimeter, 1000 micron filter. So we could run it through the flow cam, which is this like cool machine that basically pumps water through like a really small tube that has a camera looking at it, and it just like photographs all the plankton, identifies them, counts them. So after getting that data, we made this chart, which we already talked about, and drew like conclusions and from that.
Yeah. Question?
May I speak?
Yes.
So, so you were just counting numbers, you weren't thinking about like the concentration, because it sounds like the two sampling methods covered very different amounts of water.
No, it's the same.
But we would run the same amount of sample throughout the flow cam.
If you're trolling, like are you covering?
Well,
all
it's a
water
bottle.
capture?
Oh, like,
No,
I don't think the amount changes within 10 feet of trawling.
And so we were at the same sites gathering samples, and that was the point of the consistent data, or that was the main idea. Consistency.
Yeah, great job. I'm curious what you like do differently if you were to run something like this again.
I don't know.
Maybe
Maybe
try
I,
closer to shore.
Yeah,
yeah,
To adjust for that current issue?
yeah.
Yeah.
Was there ever a slack tide, like you used during the slack tide?
I don't know.
yeah, it's a slide. Yeah.
What was the most interesting, what's your favorite zooplankton after being able to visualize and view?
It's in an nauplii.
I'd say the
these
nauplii,
pictures.
but I had a favorite phytoplankton, the little tripose thing. What are they called?
Tripose?
Yeah, the tripose. Yeah, they're like,
Toxic
they're the
ones.
toxic ones.
Yeah,
Yeah,
You
we,
find them?
we always found them, and they get scared. And they're like, yeah, we're gonna have to collect this data and send it back to like,
yeah.
They had personalities?
no, I was.
They do?
They're like, they look kind of.
Yeah, thank you.
Which I do want to see. Yeah, something, I did this side. Okay. You want to introduce yourselves? Yeah. You can go first.
Okay, I'm Annabelle. I'm Carrie. Our research was on zooplankton. Our research question was, how does the amount of zooplankton fluctuate offshore versus onshore throughout the day? So our hypothesis was that we think that the zooplankton will be found on the surface of the ocean, like more zooplankton on the surface at night than at day. And we also thought that we'd find more onshore than offshore because it's like away from all the currents and like all like the busy traffic of boats.
So we weren't quite sure. We were just kind of like trying to figure out whether more would be found inshore versus offshore. We didn't have any super concise ideas about why one would be found closer to shore or out at sea, but we came to some conclusions afterwards. So first, some background though. So we learned a lot about plankton in general in our time on Hurricane, and there's two types of plankton. One is phytoplankton, which is basically the photosynthesizing plankton, and that tends to live like closer to the surface, get more sunlight, you know. And then zooplankton are bigger plankton that eat phytoplankton. So some types of phytoplankton are dinoflagellates and diatoms, and some types of zooplankton are anoplii, rotifers, copepods, daphnia. Yeah, okay. So there's some need to know info. This is kind of what we based our project off of. We knew this kind of before we started. So phytoplankton are known to vertically migrate up and down from like the depths of the ocean up to like the surface throughout the day, because they're at the surface to get more light during the day to photosynthesize, and then at night they tend to like just drift farther down. They don't need to be up there. And since zooplankton consume phytoplankton, they typically want to be at the top of the water, surface of the water during the night, because if they're up there during the day trying to feed, they're likely to get eaten by other like filter feeders like whales, fish, you know, that kind of thing. So we were pretty sure that we would find more zooplankton on the top of the surface of the ocean at night than at day. But we really wanted to do research to determine whether zooplankton were evenly distributed like throughout the ocean's surface. So if there would be more like near the hurricane's dock than like just completely out at sea. And then should be methods. Yeah. Okay. So our methods for collecting data. Off the dock, we had no need to use like a Niskin bottle like the other group used. That's like if you want to measure a certain depth of water. So like if you need to get a sample from 8 feet deep, you would send the Niskin bottle down and it, like captures that. But we were just towing the surface, so it was a little bit easier for us. We use like a plankton tow bottle, which you can see here. It's you basically just hold the net and like pull it through the water a few times. And so like our inshore sample, we were calling that the dock. It's like very close to shore. It's probably like 3 meters out. It's good. And then for offshore sampling, we took Sunny out, which is like Hurricane's boat, and we did plankton towing at like one site, which was near lobster traps. So it was pretty out to sea. It was probably like 5 minutes out, you know? Yeah, okay. And then so once we had our samples, we did some data processing. So we filtered all our samples through a less than 100 micron filter, so that the zooplankton, like any like debris in the water would get filtered out, but then like the zooplankton would still be in the water. And we had to filter it because next we ran it through the flow cam, which they talked about. But we didn't want to like damage the flow cam, have anything get stuck in it, because the tube that you run the water through is like incredibly thin. So
Like the size of a hair.
yeah, it's like really thin. You have to have like crystal clear water. So yeah. And we got pictures of all our plankton from night and day, both sites. And then we were basically able to just count up the amount of zooplankton as a whole in each like sample that we took. So then results.
So for our like our site one, which is like by the lobster traps and like out far out. And like during the day and night, we got 0 zooplankton, which really surprised us. And at the dock, we got 7 during the day and 10 at night. So we just kind of like assumed that because like at site one, it's like far, there's like currents and just like boat traffic and stuff going through that it wasn't like a good like living condition for the zooplankton. We got like a little graph.
I got a little graph here. A little graph. You can see the dock, there was more at night than at day, which is basically what we expected with the feeding patterns of the zooplankton. So both our hypotheses were technically correct. The one about finding more zooplankton inshore was very correct. So we had a few ideas for the lack of zooplankton offshore. We think that maybe we were just sampling in like not a good spot. Like there are zooplankton out in the ocean, like offshore, way offshore. but we were sampling in an area next to a lot of lobster traps. So there was like a lot of boat traffic going through. We think the zooplankton might have just gotten like mixed up in the water. So they weren't even near the surface in the night where they should have been. And then we also thought that there might be less zooplankton as a whole in the middle of the ocean, because phytoplankton tend to live closer to like the shore. And if that's their prey, zooplankton aren't gonna wanna like just be out in the middle of the ocean doing nothing, having no food. These are just some cool little pictures that we actually got from the flow cam. This is Anopheli. These are the ones we found the most of. The other group was talking about. We also found Abednias up there. These are copepods. We found some of those too. It was pretty cool.
A little rotifer.
Rotifer, yeah, it's the types. Okay, I think that's it. Questions, yeah. Anybody want questions?
So the photos, what's the scale? Like are
It's,
those compared to, like, that's what they would look like if.
If they were all next to each other,
Yeah.
this is like what they would look like. They're all to scale. Like,
they're,
no,
it's not scale.
well, no, like they're all to scale in relation to each other, like.
They're like,
But it's one, I mean, like the biggest one, is that comparatively the biggest one, even if they're all.
Yeah,
microscopic?
yeah, that's what I mean, like they're like relatively to scale to each other, not in general, obviously.
The biggest one is probably like 800 microns.
yeah.
Yeah, probably, makes sense.
So less than a mil.
Oh, yeah,
So square centimeter would be shrunk down to what?
that's a centimeter, a millimeter is 1,000 microns,
So
right?
they're all
No,
less than
yeah,
1
okay,
Oh.
yeah. You can if you have like a glass of water, you can see little dots like moving around, but not really. It's like it's really hard to see. You definitely cannot see phytoplankton. Phytoplankton are much smaller.
1,000.
Yeah.
And are they susceptible to like how hot it is? Do you see less when like the weather is really hot, or
We didn't really look at temperature.
We didn't look at temperature, but
you gotta come back and do that?
yeah. If,
Is it, cause would it be higher, like? than-
I think that you would probably find more zooplankton if it was like warmer, like in easier conditions to live in. Yeah.
The metabolism's fast.
Yeah. Okay. Good. Two more questions? We're good? Yeah.
What was the most interesting part of this experiment?
I'd say the flow cam.
I'd say the flow cam was really cool to use. Super grateful for Callie and Maya bringing that out. That was cool. It's like a really expensive piece of equipment that we do not usually get to use, so that was really awesome, because you can look at zooplankton under a microscope, but they're all like swimming around, so if you're wanting to count them, it's like pretty much impossible. Like you can do it, it's just like really painful. So like having the flow cam is really awesome. Okay, anything else? We're good? Okay.
You can read that side if you want.
I'll leave this side. So, we did have this, basically affect the transparency of, the zooplankton. Phytoplankton, so our background was basically that they're, photosynthesizing autotrophs, and we mostly focus on, diatoms, which is a type of plankton. It is one of the most common species of, in the Gulf of Maine here. And our question was like, how does the death affect their photosynthesis? Because they're a type of plant. So our hypothesis was basically at the surface, they'll have more like transparency than in the deep.
And transparency is a measurement of how well light travels through the organism. And transparency is measured between 1 and 0. More transparent, the closer to 1 it is. Our methods were, for the surface sample, we used the plankton toe and then prepared the sample
for the flow cam to take pictures. And then for the pictures, we analyze the sample. And then at 8 meters, we used the Niskin bottle. And then did the same thing, preparing the samples and then using the flow cam to take pictures and then analyzing those pictures. In conclusion, it was found that that diatom chains closer to the surface were more transparent than the ones at 8 meters. And then we had our data table over here. And then we have pictures of the diatom chains here.
Yeah, so any questions? Yes?
Did you use your own scale to, for transparency, or did FlowCam have?
Flow cam automatically
Yeah.
does it. We can like
Nice.
pick which ones we want. It just does it for us.
And it tells you
Yes.
how transparent.
Yeah. It like gives us a number.
I haven't used that on the FlowCam. It's really
It was
cool.
pretty cool.
Yes?
What kind of numbers were you guys getting, like around what range for transparency? For site 1 at the surface, we got 0.68. And then for site 1 at 8 meters, we had, I think how many we had, but the average was 0.73. And then for site 2 at the surface, it was 0.76. And then at 8 meters at site 2, we didn't have any. Cool, so it's like pretty transparent.
Yes.
So your thought is that phytoplankton need less chlorophyll at the surface because they're getting more light, and then when they get down deeper, they need more chlorophyll, so they're gonna be less transparent? Is that kind of the brunt of your hypothesis?
Yeah.
Thank you for explaining.
All right, I think that's it.
I can wait to be posters. Unless you wanna keep poster.
Yes, please. Thank you.
Terrific job, everyone. My name's Will Galloway, and I'm the Director of Education and Programs for King Island Center for Science and Leadership. I want to just say a couple of things. One is a mentor of mine, Bob Rowe, once said to me, in terms of engaging life, he said, "Be bold, persevere, and thank those who've helped you along your way." And what I want to say, listening to all of you, is that nice work. You definitely demonstrated being bold on so many levels with your research and just being out on the island doing this kind of program. And also persevering when you had some of the challenges here with research, with what happened out on the island on different occasions. You totally persevered. And so here we are. I want to just also take this opportunity to give thanks to all those people who helped you along your way, including your parents. So a little round of applause. And I want to thank also the interns, both of you from Maine Maritime. Carrie for helping, to make that happen, bring the flow cam. And of course, your teachers, your educators. So thanks for joining us. We hope to see you again out on Hurricane Island before too long. So great work.
I just want to say something real quick. If we could have you guys with your posters up at the front so we could take a picture for our presentation that we also have. So that's
Okay, so just stand up here.
You need to go up or down?
Yeah. Get a little closer, Alex. Get all close. Yep. Perfect. Do not go there.
No, come on, yeah, let's. We'll take the good one, then we can take a silly one. All right, smile pretty, everybody. Beautiful, now you can be silly if you want. I also just want to say I am so proud of all of you. You guys worked so hard and these were absolutely incredible.
So great job.
Oh, yeah.
We've got some food and refreshments in the back if you'd like. So feel free to.
Yeah.